Hello, and welcome to Math 127 for the summer. The course objectives for this class are to learn and understand the principles of derivatives, apply the knowledge of derivatives to multiple disciplines such as economics, biology, and chemistry. We'll look at how these things relate and how to best apply them for given majors. We'll start with Chapter 1, Section 1, which is what is a function? Well, think of a function like a CD player. The music that comes out depends on which CD you put in. For example, if you put in an Eagles CD, you're going to get a very different sound out than if you were to put in a Beethoven CD. So here, what music comes out depends on what you put in. Functions work in the same manner. What comes out of the function, or the y value, is going to depend on what you put in, which will be our x values. Let's look at an example of a function. We have the function y equals f of x, which should equal 6x minus 7. Let's look at what happens when we put in different inputs. If we let x equal 0, then we have 6 times 0 minus 7, which will give us a corresponding y value of negative 7. If we now let x be 3, we'll have 6 times 3 minus 7, which will give us a positive 11. X can be of any form, like fractions as well. So let's look at x equals half. If we let x equals half, we have 6 times 1 half minus 7, which equals 4. X can also take on negative values. If x equals negative 2, then y will be negative 19. So here you can see that for different values of x that you plug in, you will get different values of y. Functions can be of many different letters, not just the letters x and y. So let's look at a couple and see how they change from situation to situation. We can look at the function s equals f of t. That means that s is a function of t. This is an equation that's often used in physics. It means that position is a function of time. Here, the s is acting as our y value, and t is acting as our x value. In the next situation, we have c is a function of q. This is a function that's often used in economics. It means that cost is a function of quantity. Other equations that may come up are p is a function of m, e is a function of u, and t is a function of g. All of the equations work the same way, just as if you had y equals f of x. So just be careful about where your variable goes, but all the math will work the same way. So let's talk about some of the terminology that's involved with functions. Here, we know we can apply this to any function, not just functions of x and y, but we will use x and y because that is the most common convention. There are two types of variables in a y equals f of x type of function, the independent variable and the dependent variable. We'll start by talking about the independent variable. The independent variable is the one that you'll be plugging into your function. In general, this will be the x variable. All the possible values of x that you can plug in are known as the domain. The dependent variable, like the name states, depends on what number you've plugged in. So, in the equation y equals f of x, y is the dependent variable because y values depend on which value of x you plugged in. All of the values that are taken for the dependent variable are called the range. Okay, let's look at an example and see how we can set our own function based on numbers from a situation. Suppose that I tell you that the price P of art is a function of its age A. So that means the price that you're going to get for a piece of art depends on how old it is. So furthermore, let's suppose that the oldest piece of art known to exist is 4,500 years old. Lastly, it's known that the maximum price anyone is willing to pay for any art at all is $10 million. Let's see what we can do with this information. The first thing we want to do is come up with an equation that will relate our variables. Well, we know here that the price of the art will depend on the age. So here, our independent variable is age, and the dependent variable will be price. So P is a function of A. Since we have numbers included, we have bounds on our variables, so we can find the domain and the range. So again, the domain is all possible values of our independent variable, which here is age. Since age can only be positive, we know that the oldest it can be is 4,500 years old, because that's the oldest known piece of art, and we know it's not going to be less than 0 because negative age doesn't make sense. So we write it as x is an element of 0 to 4,500. The square brackets allow us to indicate that the endpoints are included. That is our domain for this situation. The range is all possible values of our dependent variable, which is price. Again, we know that price is only positive in contextual situations, and we know that the maximum price is stated as $10 million for any piece of art. Therefore, our range can be written as y is an element from 0 to 10 million. Let's keep the same example and talk about what other numbers might mean. So again, P is the price, A is the age. What do we talk about when we say f of 350 equals 54,000? What does that mean? Well, since price is a function of age, and age is what we plug into the function, here 350 has to be our age because that is the number that we are plugging in. So therefore, 350 is how old the art is. So our piece of art is 350 years old. And we know that the number that gets spit out on the other side, or the dependent variable, is our price. So in this situation here, we are saying that a piece of art that is 350 years old will sell or will cost $54,000. We can also look at functions by graphing them. We can say how x and y are affected by the other variable with lines and points. So let's look at some on a graph. On the graph in front of you, you will see that on the x-axis, which is the one on the bottom, the numbers range from 1 to 4. On the y-axis, which is the vertical one that goes up and down, we start at 0 and go up to 5. Graphs can be negative as well, but in this case we're just looking in the positive quadrant. So let's look at some of the points here. We have f of 1 equals 4.25. That means that when x is 1, because that's the number we're plugging in to our function, the y value is 4.5. You can see that that is the first point that's plotted on our graph. F of 2 equals 2.5. So we go over to x equals 2, and we go up to y equals 2.5, and that will be the second value on our graph, and you will see that I've drawn a line to connect those 2 points. The third value is f of 3 equals 3.5, and then we have f of 4 equals 4.5. These are points on the graph, and then as you plot them, generally you connect them with a line. Tables work in a similar fashion to graphs, so let's look at one and make sure we can evaluate the information. Let's start by looking at f of 4. When we want to find f of 4, that means we want to find the value of y when x equals 4. So we look at our table and we look for the x value of 4. So in the top row, if you go over to x equals 4 and you look directly below it, you will see the number 15. That is the f of x value when you've plugged 4 into your function. So this is the y value. So here, f of 4 equals 15. Similarly, we can look at all the numbers on the graph. So this means that f of 1, when x equals 1, will give us 3. That's the y value. F of 2 is 7. F of 3 is 11. So on and so forth down the table. Now would be a good time to attempt to do the homework for Chapter 1, Section 1.